Now, we already know that electrostatic charge is the basis for their destructive power. It is this charge that allows plastic particles to cling to membranes, cross biological barriers, including the brain, bind to proteins, and interfere with genetic processes. The charge transforms plastic from something inert into a tiny, yet powerful destructive force within the biosphere and humankind. Understanding this, the Scientific Group of ALLATRA was the first to propose a strategic direction, that is, to deprive nanoplastics of their ability to accumulate and retain electric charge. Note that countless nanoparticles exist around us, yet most do not penetrate or destroy our cells. Only plastics do because of their electrolyte behavior. Thus, if we can eliminate this property, then we can turn micro-nanoplastics into inert and harmless particles that no longer pose danger to us or to the biosphere. Now, how did the Scientific Group of ALLATRA come to understand this and become the first to propose a solution? The answer goes back many years and to the work of Dr. Igor Danilov, a vertebrologist and researcher who spent many years studying spinal diseases. Over 20 years ago, he was actively engaged in scientific research focused on investigating degenerative processes in intervertebral discs. His work included a comprehensive experimental and clinical study to understand morphological and biochemical changes occurring in the nucleus pulposus, intercellular substance, and cartilaginous tissue of intervertebral discs. While studying cellular processes, Dr. Danilov focused on immune regulation and pathological reactions that could trigger cell degeneration. He noted that mitochondrial dysfunction was one of the main drivers of these changes, and this insight became the starting point for investigating what might be disrupting cellular function. Dr. Danilov frequently visited specialized laboratories, and in the course of detailed analyses, he found foreign particles inside the cells, which he later identified as plastic. This discovery became a key moment in his research, as he began to analyze possible mechanisms by which plastics affect cells. Through his investigations, Igor Danilov determined that the negative impact of tiny plastic particles on cells stems precisely due to the damage they cause to mitochondria. This conclusion was based on observations that cells containing these tiny plastic particles showed clear signs of mitochondrial dysfunction, which in turn exacerbated degenerative processes. Here, Igor Danilov suggested that the ability of plastic particles to penetrate cells may be due to their electrolyte behavior. That is, the ability to accumulate and retain electrostatic charge, which allows them to form a biological shell around themselves. This property enables the plastic particles to enter cells easily, avoid detection by the immune system, cross protective biological barriers, including the blood-brain barrier, disrupt normal cell function, and provoke degeneration and cell death. On this basis, Igor Danilov proposed that to neutralize these tiny plastic particles, we must deprive them of their ability to accumulate and retain charge. He shared his findings and projections about the harmful effects of tiny plastic particles with his colleagues from various medical fields, including surgeons, oncologists, cytologists, pathologists, and geneticists, as well as with biologists and chemists. Soon after, these specialists confirmed his alarming observation that these plastic particles do accumulate in critical organs in the body, such as the brain, heart, intestines, endocrine, and reproductive organs, where their presence can disrupt organ function and destroy our health. Igor Danilov's predictions were deeply concerning, especially in light of global trends, the rising production of plastics and the growing accumulation of plastic waste in oceans and ecosystems. Thus, more than 20 years ago, the Scientific Group of ALLATRA realized that micro and nanoplastics pose a serious threat not only to humans, but the entire biosphere. And each year, the number of these particles continues to grow, worsening the situation amid accelerating climate and geodynamic changes on the planet. The implications are far-reaching. If we can eliminate the charge from micro-nanoplastics, we will not only eliminate their destructive impact on human health, but also remove the excess energy accumulating in the biosphere, the energy that currently fuels the geodynamic crisis and intensifies natural disasters. Thus, plastic would no longer act as a destabilizing factor, and many planetary threats could be mitigated at once if we can find a way to deprive nanoplastic of their ability to accumulate and retain charge. The question is, how can we achieve this? Well, let's be honest. This task is extremely difficult. It will not be enough to simply figure out how to neutralize the electrolyte behavior of these tiny plastics in a test tube. We must learn how to achieve this for every micro and nanoplastic particles already present in the biosphere, including those inside a human body, and do so without harming people or nature. Given the unprecedented scale of this challenge, solving it will require collaboration among experts across many disciplines: biophysics, nanotechnology, molecular toxicology, material science, and medicine. Plastic pollution is not a narrow environmental issue. It's a systemic global challenge that affects health, safety, natural resources, the stability of our civilization, and life itself. 20 years ago, the Scientific Group of ALLATRA already recognized the danger of micro and nanoplastics and identified the underlying principle of how they could be neutralized. But to this day, we haven't found a way to achieve it. That is why ALLATRA calls for unification of the world's scientific potential, a message that is unfortunately often misunderstood. Uniting scientists doesn't mean locking them all in one giant laboratory until they find a solution. Rather, it means fostering open international collaboration where experts from different fields freely share knowledge and work together toward a common goal. It's about aligning research methods, promoting open data exchange, developing compatible monitoring tools, and making coordinated policy decisions. The scientific community has already proven that such collaboration is possible when humanity unites around a common goal. Consider the Human Genome Project. Hundreds of institutions across dozens of countries, operating under unified data standards, achieved a breakthrough that transformed the course of science and medicine. In the same way, addressing the plastic crisis will require global cooperation, a collective effort to protect both ourselves and our planet. The ALLATRA International Public Movement actively supports the initiative of Pope Francis, Laudato Si', which seeks to raise the awareness of the importance of protecting our common home, the planet Earth. It is very important to emphasize that Laudato Si' is far more than just a call to care for nature. It is a practical and scientifically grounded guide, a roadmap for transforming our world and creating a better world for future generations. The encyclical provides a clear direction toward a sustainable future, uniting ecology, climate justice, and humanity's shared responsibility for protecting our common home. The ALLATRA movement, fully embracing these principles, views Laudato Si' as a powerful catalyst for global cooperation in addressing environmental and social challenges, and preserving the delicate balance of our planet. Cardinal Peter Turkson, the Chancellor of the Pontifical Academy of Sciences, is widely recognized for his dedicated work in ecology and social justice. Thanks to his educational efforts and tireless advocacy, the encyclical is widely disseminated worldwide as a practical guide for safeguarding our planet. It is a great honor for us to introduce Cardinal Peter Turkson, who will speak about the efforts being made to promote the encyclical Laudato Si' and to put its principles into practice.
So question is, how can we get Laudato Si to be widely read? Of course, the book that is there. I have presented it at the United Nations. I presented it at UNESCO in Paris. I presented it at Davos World Economic Forum. So I've talked about Laudato Si in several environments. I've also had a chance to present it even in university groups. Ohio State was the first group that wanted to hear about Laudato Si. And since then, I've been in Dayton, I've been in San Diego. And therefore, to get Laudato Si well known, we decided to create what we call Laudato Si Action Platform, which identified, in fact, 7 actors of Laudato Si. So churches means churches, mosques, synagogue, all places of worship, places of studies, basic university type of studies, educational centers, offices and factories. So we identified these 7 groups and say, okay, follow a team for 7 years and see what you get. Okay, all of that was to popularize the content of the encyclical Laudato Si and to encourage and enable people to put it into action or practice. So it's not just something written, but something that's actionable. And 10 years now, okay, this is 2025. Laudato Si was published in 2015. It's difficult to identify or talk about places we still have not heard of it. Personally, and from the point of view of our force, we've had occasion to kind of talk about this to different audiences and constituencies, but I still would not say that because of that it's known worldwide and by everybody and for everybody. We've tried our best and we'll continue to talk about it. And Pope Francis, to give this a big push, decided to create what they call Borgo Laudato Si. Over here in Rome, another initiative to get it known has been the development of what they call Laudato Si Diploma. There are various initiatives trying to do this. And the moment we get this established in universities, it attracts a lot of young people. And so, it becomes an occasion to spread knowledge of Laudato Si words.
For its scientific and social contribution to the protection of our planet, ALLATRA received the blessing of His Holiness, Pope Francis. This spiritual encouragement to continue working toward the preservation of our planet greatly inspired the participants of ALLATRA and motivated them to pursue a deeper research into the problem of nanoplastics, a growing threat to all humanity and its future. This effort resulted in the publication of the scientific report, Nanoplastic in the Biosphere, from Molecular Impact to Planetary Crisis. And this was presented for the first time in May 2025 at the International Conference of the Centesimus Annus Pro Pontifex Foundation in the Vatican by the President of ALLATRA, Marina Ovtsinova. This documentary is based in part on that scientific report. Such fundamental study into the threat of nanoplastics became possible through the international cooperation between the Scientific Group of ALLATRA and the Bolivian Catholic University, San Pablo.
We are a research team from the Bolivian Catholic University, San Pablo in Cochabamba. Our work seeks to understand how micro and nanoplastics circulate through our environmental matrices, how they interact with other pollutants, and what implications this has for human health and the biosphere. As part of the academic cooperation between the Bolivian Catholic University, San Pablo, and ALLATRA, we jointly prepared the report, Nanoplastics in the Biosphere, From Molecular Impact to Planetary Crisis.